All right, we'll get started. In the Chem 1 course, on the right-hand side, you'll see in the upcoming this activity series lab. Now, this is the lab that we would have done today, and we were going to hold off and do it tomorrow, but this snow is going to continue, so it's possible we might be remote again tomorrow. So what we did was we got the lab all ready, and then yesterday, my wife and I, Dr. Flint, we were up at the school and got the lab going and made a series of videos of the lab experiment itself. So if you click on the lab for the activity series lab, you'll find that it's a document like a, oops, I gotta log in. It's a OneDrive document. Now, if you happen to have a printer and you can print it out, that's cool, but you don't have to write it on a printer at all, or like have the actual document. So the top says, I don't know why it's not loading here. It just says activity series lab. So what we've looked at is the activity series. And on the activity series, you can compare whether or not a reaction will take place and predict whether or not products will form based upon the positions of the metal on the activity series. For instance, if you have potassium and lithium chloride or lithium and potassium chloride, one of the reactions exists and one of the reactions doesn't. If you look on the activity series, if potassium is above lithium, then the reaction will proceed and it'll make lithium and potassium chloride. If, on the other hand, lithium's above potassium, then this reaction will proceed. But basically, only one of the two reactions will happen. And a reaction occurs generally if it's a metal and some kind of ionic compound like potassium and lithium chloride, if the metal that's by itself, the elemental metal, is above the metal that exists in the compound on the activity series. So what we want to do is figure out, based upon observing experiments, whether or not some reactions take place. So the regular procedure is that there's some different kinds of metal. And in this chart, this is the kind of chart that if you can't print this out, you just want to write it on paper, just kind of like draw this chart. Basically, we have 4 different metals: magnesium, iron, copper, and zinc. And we're going to react magnesium, iron, copper, and zinc each with these different solutions. These are different nitrate solutions: magnesium nitrate, iron nitrate, copper nitrate, silver nitrate, lead nitrate, and zinc nitrate. And the reason why there's X's in these boxes is because if you try to react magnesium with magnesium nitrate, it turns out nothing happens. And that's because the only way that a replacement reaction occurs is if the metal, which is on the left-hand side of the chart, is above a metal that is in a compound, like in solution. And it turns out that if you have magnesium and magnesium nitrate, there's no reason for magnesium metal to replace magnesium in the compound. That just doesn't happen. So that's why there's X's in a bunch of those boxes. There's no silver and lead. We didn't react silver and lead with the different things, so there are really only 4 different kinds of metals. But basically, we've got well plates in which we place pieces of magnesium in iron nitrate, copper nitrate, silver nitrate, lead nitrate, and zinc nitrate. Same thing, we place pieces of iron in magnesium nitrate, copper nitrate, silver nitrate, lead nitrate, and zinc nitrate, and so on and so forth. So the plan is to put those pieces of metal in the different solutions and look to see whether or not reactions take place. Look for bubbling, look for the metal to break down or change color, look for some production of gas. That's what bubbling really is. Look for a change in color of the metal, thinning of the metal, change in color of the solution, any kind of changes that take place. And then the liquid's removed from the solution and you can pull the piece of metal out to take a look. So there's hold on, there's something going on outside our house. Just looking out the window, there's some drama with the neighbors. I don't know what they're doing. Okay, so what we did was did those reactions and videoed the reactions for you. And what you want to do is, based upon the observation of the reaction, which of the metals is the most reactive or the highest on the activity series. So the way you can make that conclusion is, as a result of watching the different reactions, one of the metals reacts with more things than the other metals did. And then one of the metals reacted the least. So what I mean by that is, let's say, for instance, you find that the iron reacted with magnesium nitrate and copper nitrate and silver and lead and zinc nitrate. There was reactions of iron with all of those substances. I'm not saying that's what happened, but let's say that this metal reacted with all those substances. You would consider that to be the most reactive of the metals. It replaced more things, which means it must be above more things on the activity series. On the other hand, if there's another metal, let's say maybe it was zinc, and the zinc didn't react with anything. In other words, the zinc, you put it in the solutions, there was no color change, there was no gases formed. If the zinc didn't react with any of these substances, then zinc must be below magnesium, iron, copper, silver, and lead. So I'm not saying if those are true. I'm not saying if what I just said is true or not, but that's the criteria you use. In the last part, this is just more practice using the activity series to determine if the reactions take place. If no reactions take place, just write NR. So for instance, magnesium and iron nitrate, the criteria is you look on the activity series, and if magnesium is above iron, then the reaction takes place, and the reaction product is magnesium nitrate, and the iron goes by itself. So all of these reactions are reactions of magnesium with the different substances that are used in the lab, and you predict the products of the reaction. And you should find that if the activity series, like let's say on the activity series, let's say magnesium is not above lead, then you would expect no reaction, and that should be the same thing as what you observe in the lab itself. Okay, so that's kind of how the lab goes. If it's up to you how you want to do this. You could fill the thing right in on the activity series thing, like write right in these boxes. You should be able to just click and type right in, and then just submit the document. If you don't want to write right in here, write your observations. And the best thing to do is just do it right in the lab. You can have one window open with the lab and one window open with the videos and whatnot. So let me show you the way to get to the videos. If you're in Unit 6, which is our current unit, you'll find, hold on a second, let me check this. Doing this in class tomorrow. Well, let me show you the thing for the week. We're not going to spend much more time here. You can do it today. So in the schedule for the week, we're kind of waiting to see what happens tomorrow, whether or not we're in school or not. But in the schedule for the week, that's why the schedule for the week doesn't have a whole lot, because what we do depends on if we can be together or not. But I'm not, I don't make the call, but if I'm a betting person, we're probably going to be remote tomorrow too, because it looks like we still got another 8 or 10 inches of snow to go right through tomorrow morning. But anyway, in the folder in Unit 6, in the folder for the week, the current week, Monday 2/1, it says watch the activity series lab videos. So it should work for you. When you click on that lab video link, it'll open up a page in Schoology, and that page has videos embedded in it, and the voice in the video, that's Dr. Flint. She's describing how everything's going here. The first one's a little bit messed up. It's kind of like a vertical video, then it kind of gets turned. But this is a description of the introduction to the lab. You can watch that. But if you don't want to watch that, you could just watch video 2. And video 2, like video 1 basically shows, how the solutions are made and put into the well plates. But video 2, it's the same organization as on the lab paper. So along the left-hand side are the 4 different rows for the different metals, and along the top are the different solutions. So it's exactly corresponding to the lab paper. So for instance, magnesium, let me see which one. I guess I can make this bigger. You can make it bigger so it looks good. So on that chart, we're not putting magnesium and magnesium nitrate. That doesn't make any sense. Instead, magnesium is going to go in with iron nitrate. It's going to go in copper nitrate, silver nitrate, lead nitrate, zinc nitrate. This is on a white background because the iron nitrate starts out as like a brownish color. The copper nitrate starts out as a bluish color. So pay attention to the fact that those start out in those colors. All the other solutions, magnesium nitrate, silver nitrate, lead nitrate, zinc nitrate, those solutions are colorless to start. So anyway, you just dump in the different kinds of metals in the different solutions. So these are pieces of magnesium going in with each of the different substances. In the first one, there's just a description, or in this video, there's just a description of them going in. And then we get back. After they've been in solution for 2 minutes, you can watch to see what happens to each of the different metals in solution. Here you can even see a little bit of bubbling forming. And then at the end, the pieces of metal are pulled out of solution, and you can compare the metals to each other. So for instance, you can probably just see it here. Let me go in. So for instance, there was copper put into these different solutions, and you see when the copper went into magnesium nitrate, it still looks nice and bright and shiny copper. So not much of a reaction took place. Similarly with the zinc nitrate. But here you can clearly see that that piece of copper, which just starts out like this, when that copper was put into silver nitrate, there is definitely a change. Oftentimes when the reaction takes place, this metal will grow what's called mossiness on it, or get darker in color. So that piece of copper is now significantly bigger and kind of like silverish or black in color. Same thing, zinc starts out like this nice silverish kind of color, and in this case it was kind of like a black color. So which of the metals was the kind of like most reactive of the reactions? So anyway, if you watch the videos, you'll be able to see what takes place in the experiment. Hold on, let's see. Oh, that's weird. Oh, I see what's going on. I'm still like in full screen. That's why it got messed up. There we go. All right, so the videos are all in the folder for the week. That's what you should do for the rest of the period today is watch the video for the lab. We won't do the lab in person. It's just going to be your observations based upon what's in the video, and that should work out okay. All right, so watch those videos and work on filling out the lab and work on practicing the problems. I will stay in the Zoom, so if you have questions and you want to stop back in, that's totally cool. Alternatively, hold on, I don't know why that's happening. Oh, there it goes. Alternatively, you could just send me a message on Schoology. But if you don't get it all figured out today, that's okay. Either in person tomorrow, or if we're remote tomorrow, I'll take questions about the lab. Just record your observations about which of the metals which metals reacted with which solutions, and that'll give you a clue as to the order on the activity series. And if you're not quite sure, if you look at the activity series, so if you're like, it's hard to tell if the copper reacted with zinc nitrate or something, if you look on the activity series and copper is above zinc on the activity series, then the reaction did take place. Some of the reactions take place more readily and are more violent. Basically, the bigger the difference in position on the activity series, the faster the reaction is going to happen. So if there's a metal that's really super high on the activity series and it could replace something that's below it, the bigger the difference in position, the faster the reaction takes place. If two things are right up against each other on the activity series, then the reaction proceeds much more slowly. But after just the 2 minutes, you'll be able to tell if there's evidence of the reaction taking place. Anyway, so that's what I've got for you today. So you don't have to stay in the Zoom if you want to work on the lab. That's totally cool. If you want to stop back in and you got questions, I can answer your questions. But that's what we're doing. Any questions, you can put them in the chat, turn on your mic. Otherwise, I'll see you guys tomorrow.